going to graph the information that we had from our data table from examples B and C and put them into a graph. So for example C, remember to graph we need a number from our x-axis first and then our y-axis. And I'm looking at example C's data table. You'll notice that the first ordered pair in example C is 1, 0. So that means I'm going to go over 1 and up 0. So I'm just going to put my dot right there. The next point was 2, 2. That's a tough one to mess up, even if you mix up your x's and your y's. Our next, x is 3 and y is 4. So x is 3, y is 4. You'll notice they're falling into a straight line, which is a good thing. The last is 4, 6. So go to the right 4 and up 6. So I'm going to connect my dots because I don't like to just leave those dots hanging. So we have a straight line. Now we're going to graph example D. Our first ordered pair in example D was 0, 0. Our next ordered pair was 3, 1. So to the right 3 and up 1. 6, 2. To the right 6 and up 2. And the last point is 9, 3. Again, don't leave them hanging. Connect your dots. All right. So we already know from our data tables which one shows direct variation and which one does not. But look at these two graphs. I suppose I should make them as similar as possible. What do you notice is different? First thing I notice is that this graph starts at 0, 0 right at the origin, and this one doesn't. It's kind of scooched over a little bit. So that's really one of the first things that you should notice about direct variation is that the graph will go through the origin, which is the point 0, 0. We can call it the origin. So you should be able to spot direct variation on a graph from a mile away. If it goes through 0, 0, it's direct variation. If it doesn't, it's not. Oh, Mrs. Trombley's prompting me here. She's like, oh yeah, there's straight lines too. Well, they are. They will always be a straight line because these are all what we call linear relationships because we're dealing with like $10 per hour, the same rate. It's a constant rate. So they all form straight lines. That's not what makes it direct variation. It has to be a straight line and go through 0, 0. So it's got to have both of those. All right. This one, probably going to be the trickiest. Maybe I'm wrong. We'll see. Okay, we're going to identify direct variation from an equation. So here we have our favorite student, Buffy. She earns or saves $7 a week, and Bifford is saving, he has $50 to start off with, and he's saving $10 a week. So we're going to use the variables x and y to complete our equations, and you'll remember that when we're graphing these, our dollar amount would always be on the y-axis, and our number of weeks would be along the x-axis. So if we were going to write an equation for how much money Buffy would have after any number of weeks, we're going to use this equation. Y, representing the number of dollars, is equal to, well, she makes $10 per week. So we know that we're going to use a 10, and we would use x to represent the number of weeks that she's worked. So if she worked 5 weeks, we would just say 10 times 5 is $50. So the dollar amount, or the y in this case, would be $50. So Biff is another story. His amount of money, he's making $10 a week as well. So you could start with that. He's definitely making $10 per week. Notice the word per. This is the one that's going to be attached to the x. This is his rate of pay, $10 per hour. But Biff has a little something extra. He's still got 50 bucks. What will we do with that? It's not 50 bucks a week, so we don't want to multiply it by x. We're just kind of going to add that to what he's got. So we're going to represent that with just a plus 50. So look at these two equations. They look similar in that they both have a 10x, But remember, Biff's got that little something extra. He's got that extra 50 bucks. So how can we identify direct variation from an equation? Well, the one with direct variation doesn't have anything extra. There's nothing extra added on. One that does not have direct variation, like Biff's, because we recalled from his data table that he did not show direct variation. Whenever there's that little extra something added on, there's not direct variation. So a couple things I'm going to have you write here for how you can identify direct variation from an equation. Direct variation will not have anything extra added to the variable term, so the term that has the x with it. And these are all going to take the form, they're all going to look just like Buffy's equations. It's going to be y equals something times x, but that something might change depending on who we're talking about. So they're all going to have a y, and they're all going to have an x, but the thing that's going to change is what's being multiplied by x. Your book is going to use this thing, and we'll call it k. So they will all have this form, y equals k times x. So we've got some equations down here, and what we're being asked to do is determine whether or not they show direct variation. And remember, we're looking for them all to look like this, y equals something times x. Well, you might be able to look at these right off the bat and notice that there's some addition signs in some of these, but we have to be very concise and make sure that we solve it properly. What we want to do is get the y all by itself, just like we were solving an equation. We're going to get the y alone. What do we have to do in this particular case to get the y alone? We got to get rid of that 1. So what would I do? I would add a negative 1 to this side of the equation. So now y is all by itself, but then I have to also add a negative 1 to the other side. 2x and a negative 1 are not constant terms, so I would write it just like this. 2x plus a negative 1. Does that look like this? Does it look like, well, let me write it right here. Does it look like y equals something times x? Nope, because it's got a little something extra. So here's one that is not direct variation. All right, look at this next example. The y is not alone, it has a 1/2. I want to get rid of 1/2. Remember, to get rid of a half, we multiply by the reciprocal. By doing that on this side, I get to cross a bunch of stuff out, and that's fun. So y is all by itself. Over here, I'm going to multiply by 2 over 1, which is the reciprocal. Well, what's x times 2 over 1? That's just 2x. Does that look like this? Y equals something times x? Nothing extra added? Yes, it does. All right. Ooh. All right, we got to get y all by itself. In order to do that, we need to get rid of the x. You'll notice that x is stuck to the y. It's being multiplied. How do you get rid of multiplying? Divide. I'm going to divide by x, and that gets y alone. So I'm going to do the same thing over here. Divide by x. So I have this, and while there's no addition in the problem, does it look exactly like this? K could be a fraction, but that's not what we're getting at here. This is not direct variation. This is going to be our next section. So we'll get back to that later. But currently, it's not direct variation. Woo! Yikes, look at this one. All right, so I have y plus 5 equals x plus 1. All I need to do is get the x all by itself. So let's get rid of this 5. So add a negative 5. So now y is all by itself. So I have to add a negative 5 over here. So I have x and 1 and a negative 5. These two are like terms. When I combine them, they make 4. So over here I have y equals x plus 4. And that does not look like this because it's like Biff. It's got that little extra something special. So we say nope, not direct variation. I hope you.
All right, hopefully you've tried this. So we're going to subtract 2 to both sides, giving us y equals x minus 2. Wait a second, it doesn't match our y equals kx form. Y equals kx. It doesn't have a minus 2 on the end, so this does not match our formula. So the answer for this is no. And please don't forget that you are supposed to explain your reasoning. Why did you say no? And in this case, you would say no, because it doesn't match the form y equals kx. All right, now that we've done worksheet number 1, go ahead and do number 2. Number 2, we have to isolate that y. So we have to get rid of that 3. You can do it one of 2 ways. Divide by 3 to both sides. We get y equals 1/3 x. Some of you might be like, wait a second, Mrs. Vincent, how is that 1/3 x? Let me show you. I'm going to quickly break it down for you. X over 3. How does that equal it? Well, let's just work backwards. If we have 1/3 x and we want to multiply, we get 1/3 times x over 1. Makes sense. Then we multiply our numerators, and guess what we get? X. Multiply our denominators, guess what we get? 3. So x over 3 equals 1/3 x. If you didn't get that, go ahead and rewind that and watch it again. If you still are lost, let's do it the front way. 1/3 x equals 1/3 times x over 1, which equals x over 3. Still works. So when we go ahead and look at this, we go, wait a second, that looks very familiar to y equals kx. And guess what? Because it is, yes, it is a direct variation. Please make sure you explain your reasoning. That means saying something as simple as, it matches the form y equals kx. This next problem, I understand this is on your worksheet. You haven't done anything like this, so I'm going to do this with you. The variables x and y vary directly. Very directly is your clue that you can use y equals kx. So now, use the values to write an equation. How do we write our equation? We have to figure out what is our k. That's not too hard. All you have to do is plug in the y and the x that you know. So 8 equals k times 2. If you didn't follow, we just plugged in 8 into where our y is supposed to go, and 2 into where our x is supposed to go. Now we just solve for our k. We're trying to figure out what is that constant. 4 equals k. So therefore, we just plug it right back into our formula, and we get y equals 4x. That is the equation. That's it. We're basically just doing it backwards. So at this point, you should know your answer, so you should write it down since I did it with you. All right, go ahead and do number 4, but I'm going to help you set it up before you do it. Write a direct variation equation that relates x tires to y cars. Let's make a quick table so you can see what it's asking. If you have 1 car, how many tires are you going to have? 4. If you have 2 cars, how many tires are you going to have? 8. So on and so forth. 3, 12, 4, 16. And then all you really have to do is pick one. I'm going to pick the smallest one. Makes it easier. X equals 4. Y equals 1. Now just duplicate what we did on the worksheet number 3. You have your x and your y, plug it in, find out what does my k equal. Once you find out what your k equal, plug it back in. If you don't know how to do this, rewind it and watch worksheet number 3 again. Alright, hopefully you plugged it in and you got y equals kx. Once you plugged it in, you should have gotten y equals k times 4. Divide 4 to both sides, so 1/4 equals k. Once you plug that back into your formula, you get y equals 1/4 x. Done. Alright, hopefully you enjoyed this lesson. I can't wait to see what you do in class tomorrow.